Hello students, so today we will learn chapter 2, which is units and measurement. Part of this chapter you have studied in previous classes, but I will do the complete chapter so that it will be total compilation and completion. Now you know the meaning of units. Like we say that length is measured in meter, so meter is called a unit, and measurement means how to measure the things. So this is the content of the chapter that we are going to study today. So first let us see that what are the various physical quantities and how they are classified. The various physical quantities are divided into two groups. One are called fundamental quantities and others are called derived quantities. Fundamental quantities are those quantities which can be defined or derived without the help of any other quantity, whereas derived quantities requires the help of fundamental quantities. For example, if I say length, so length can be defined without the help of any other quantity. So these fundamental quantities cannot be resolved into simpler parts or simpler quantities. So their units are also called fundamental units. So fundamental unit of length we will be learning in SI system is meter, in CGS system is centimeter. Now derived quantities take the help of one or more fundamental quantities, and based upon the relation between that quantity and fundamental quantities we can tell its units. For example, volume. We know volume is length multiplied breadth multiplied height of a rectangular parallel pipe. So all are measured in same units. So we'll say L into L into L. So that will give me L cube. So it's in SI system its unit would be meter cube. Now density is mass upon volume. So unit of density would be kg per meter cube or kg m raised to minus 3, because mass is measured in kg and volume is measured in meter cube. So for derived quantities we should write the relation of derived quantity in terms of fundamental quantities and we will get the units. So now we will try to understand how to measure the things. Like if I tell you to measure the length of this room, you will bring a meter scale and you will say that it is 5 meters, because it is 5 times the meter scale. So we compare the number of times with the units. So measuring is always a comparison. Like mass is measured by physical balance. On one side you will put a 200 gram weight, other side you will keep some good, and when they get balanced you say this is also 200 gram. So we are comparing it with the standard units. So that is a measuring process. Long back, many hundreds of years before, like if you will say I want this rope, so he will stretch his hands and measure the length and say okay, this is 1 unit. Now how many you want? We will say 10, so he will give you 10 times of that. So that was not scientific, but now our things are well defined, so that in case you buy from any place in the world, then you will get the same quantity. So if you are buying 5 meter length of rope, you will get the same length of rope anywhere in the world, because 1 meter has been standardized. We will be learning that how is 1 meter defined. So now we can say that the quantity is equal to n multiplied by the unit. Unit is written by U. So we will say Q is equal to n multiplied by u. It is written here. So Q is equal to n multiplied by u. Okay, so you can see here Q is equal to n multiplied by u. So n is number of times, u is unit, means one length. Now, if the same things, if I would have measured this length of the room from by using a centimeter scale, then I would get a very big answer, means I will get 500 centimeters, because now it is 500 times the length of 1 centimeter. So what relation so we are getting? Q is equal to n1 u1 equal to n2 u2. So any same quantity, if you are measuring in different units, the number will change. And in case the quantity is bigger, like meter is bigger, so its number is 5, smaller. Centimeter is smaller, so its number is bigger, 500. So Q is equal to n1 equal to n2 u2. This will be using in certain examples. Is it all right? So now we'll proceed further. Now what are the characteristics of a physical unit? How I should define, like distance between hands of two hands is not desirable, because it is not well defined. Our things should be well defined so that everyone will get the same answer. Like how we have defined 1 meter, we will be learning in the next slide. It is the distance between two hairline marks in platinum iridium rod. So there is a rod kept in Paris which will not expand. So there are 2 marks here. So this length is said to be 1 meter. So so this length 1 meter has been given to all countries. In case anyone has doubt, this is the standard. We can measure it. So this is preserved in Paris. Is it all right? So, but now we have got other systems, or better system, so that we need not depend upon this rod. So our unit should be of convenient size, neither too large nor too small. So should not measure the length of the room by millimeter. It is a too small a size, millimeter, and neither with a bigger scale like ounce, like AU. AU is the distance between Earth and Sun. So that cannot be used. So we should always use a convenient size. It should be easily reproducible, so that anybody using it will get the same answer. It should not change with time and from place to place. If today you are measuring something and if the thing remains same, then after many years also if I measure by using the same standard, I should get the same answer. It should be imperishable. So it not changes. It should not be affected by pressure and temperature as far as possible. Therefore, we have chosen the material such that its temperature coefficient of expansion is almost 0. Is it all right? It should be easily accessible. So now we will come. So various countries had adopted various systems. So, but 4 systems are commonly used. One is CHUGHA system. So this was set up in France. Always in the earlier times, length, mass and time, these were the 3 physical fundamental quantities. So length was measured in centimeters, mass in gram, time in second. So this is a decimal system. It means if I convert its smaller unit to bigger unit, or a much smaller unit, then it will be only multiples of 10. Like 1 centimeter is equal to 10 raised to minus 2 meter. And 1 centimeter is 10 millimeter. So it is always multiples of 10. To 10, 100, 1000. So that is called a metric system. So it is always 10 raised to some index. Okay, so that we call multiples of 10 or some multiple. In FPS system, length was measured in foot, mass in pounds and time in second. Now this was a British system. Nowadays we are not using because it is a bit inconvenient to use it as compared to metric system. Then we have got MKS system. MKS system is similar to CGS, only its units are bigger. Length is 1 meter. You know 1 meter is 100 centimeter. Mass is kilogram, which is 1000 gram, and time is measured in seconds only. And now we have added one fourth fundamental quantity called for electric current, which is ampere. So now we are using ampere also. This is the fourth fundamental quantity we are using in ampere system. Now, as there were various systems, so all countries has not defined system international of units. So that throughout the world we are using now SI system. So in case you want to write any research or scientific paper, the unit should be SI. So we will be learning now this in detail. In this system, instead of 4 fundamental units, we are having 7 and 2 supplementary units. We will study now about them. Now you see, the 7 quantities are listed here. Length you are familiar, its unit is meter in SI and its symbol is small m. Mass, kilogram, kg. Time, second, S. Temperature, Kelvin, K. K is capital. Electric current, ampere, capital A. Luminous intensity, candela, CD. I will explain this in the next slide. Quantity of matter, mole. You know, we have studied in chemistry what is 1 mole. 1 mole means number of molecules, ions, or any other thing equal to Avogadro's number. Avogadro's number means total number of atoms that are present in 12 gram of carbon. So that number you know is 6.02 multiplied by 10 raised to 23. So like if you are buying 2 dozen banana, means 2 multiplied by 12, because 1 dozen is 12. If you are buying 1 dozen oranges, means 12 oranges. So similarly, when I say 1 mole of what? 1 mole means 6.02 multiplied by 10 raised to 23 quantity. So I have to say 1 mole of ions, 1 mole of molecules, 1 mole of atoms. Okay. Now, plane angle. Now you see, this is a circle. This radius arc length is r. It is making angle theta. Always this angle is theta. If this arc length is r, radius is r, then value of this theta is 1 radian. This is how 1 radian is defined. Angle subtended by an arc of length r, which is equal to radius of the circle. So then this is 1 radian. Now what is the total length of the circle? 2 pi r. So r means 1 radian. So 2 pi is the total arc length. So 2 pi r divided by r will give me 2 pi. So the angle made by full circle is 2 pi. 2 pi radian. In radian it is 2 pi. In degrees you know it is 360 degrees. Now similarly, now today we are defining solid angle. Now instead of this circle, I am taking a sphere of radius r. If I take a sphere of radius r, then it will have a surface area on its top. So on its top it is having surface area. So if the area of that, if I take r square, then the angle made at the center, it will be a solid angle, like cone that you eat. So that angle would be called 1 steradian. Like here I call 1 radian. Now total surface area of a sphere, you know, is 4 pi r square. So if the area is r square, angle is 1 steradian. Now area is 4 pi r square, so angle would be 4 pi. 4 pi r square upon r square. So that would be that 4 pi r square upon r square. So that will give me 4 pi. Because this is total area and this is r square means 1 steradian. So I am getting 4 pi. So the angle made by sphere is 4 pi. Is it alright? So now, as I was telling you, I will explain all the units. Meter. You know, it is meter is unit of length in SI system. So it is distance travelled by light in vacuum. So what is the distance travelled by light in vacuum? vacuum in how much time? In 1 upon this number. This number is nothing but 3 into 10 raised to 8. We do know speed of light is 3 into 10 raised to 8, but this is very accurate. So in this part of a second. So as you know, speed is distance upon time, isn't it? Speed is distance upon time. So distance would be speed into time. Speed is also this, and time is this. We have to divide by this 1 upon this. So speed is 299 and so on, and multiply by 1 upon this number. So this will get cancelled, so I will get 1. Therefore 1 meter. So now this is, no ambiguity is there. Anybody can do in the experiment. You take in vacuum, you see how much distance light travels in this amount of time. Now 1 kg is the mass of this platinum iridium cylinder kept in Paris. In Paris they have kept one cylinder, so its mass is 1 kg. And they have given of this similar mass to all the countries of platinum iridium. You can also have it, and in case anybody is having doubt, then we will compare it with this standard. Now second, time. It is defined as time interval in which the cesium 137 atom, it is changing its state. We will be learning later on what does it mean. So when it is making so many vibrations in 1 second, that time is 1 second. So this amount of vibrations it is making in 1 second. Ampere also we will be learning in 12th standard when we are doing chapter of current electricity. These are the two conductors of negligible cross section and of very long length, or infinite length. The distance between them is 1 meter. So this is 1 meter. Now whenever the current is flowing in the same direction, this conductor attract one another with a force. So if my current, I will adjust to such an extent that the attractive force is 2 into 10 raised to minus 7 Newton per meter. So in any 1 meter length, the attractive force is this value. So when this is the value of the attractive force between two conductors, means the current flowing in both is 1 ampere. Then Kelvin. Kelvin is unit of temperature. Like you might have seen, solid ice and water in equilibrium at 0 degrees C. Similarly, I can have solid, liquid and water, all three at equilibrium. Then if I take this fraction of that temperature, 1 upon 273.16, I will get 1 Kelvin. Now mole I explained you. Mole means I should take 12 gram or 0.012 kg of carbon 12. The number of atoms this is having, that number is this Avogadro's number. So 1 mole means number equal to this. So I should always tell 1 mole means what? 1 mole of molecules, 1 mole of atoms, 1 mole of sodium ions. So that's the meaning of 1 mole. Now I will come to candela. Now candela means how much is the brightness of the light. If there were two different bulbs, then at the same place, if you switch on each bulb one at a time, the brightness may not be same. So its unit of brightness is candela. So if I take a source of light, then in a certain direction, but now to define 1 candela, I will take source of light which will emit light of this frequency, 540 into 10 raised to 12 Hertz frequency. So if the light is of this frequency and my radiant angle is 1 steradian, the light is getting emitted, then in 1 steradian angle I am getting a power of 1 upon 683 watt. If I get this amount of power of light, then the intensity of light is 1 candela. This also we learn when we do optics. Then supplementary units, this I explained to you what is radian. Angle in radian is arc length upon radius. This formula you should learn. isn't it? Radian is arc length upon radius. Arc length is 2 pi of full circle upon half, so angle is 2 pi. So 2 pi radian is 180 degree, so 1 radian will be 180 upon 2 pi. If you calculate, you get 57.3 degree. Then we go to steradian in the same manner. Now this is 3-dimensional. So if I am having a sphere, and if I take area of a sphere equal to 4 pi, area of a sphere equal to r square, then for one steradian angle will get formed at the center. Therefore, as the total area is 4 pi r square, and if the angle is r square, area is r square, angle is 1. So now this is 4 pi r square, so angle would be 4 pi. So this is about the various units